The next skill that you really need to have for AP Physics is manipulating equations, and it's very important on the test that you're able to do this. A lot of times they'll ask you just derive an equation, which just means set up the variables that you would do if you did have numbers. But they don't actually ask you to solve the problem and get a final numerical answer. So you really need to be able to look at variables, understand how to manipulate the variables, move things around, because it may ask you to just do that and not solve for a number. So just remember the opposite operation is always needed to move things from the right side to the left side or left side to the right side of the equation. So if you have multiplication, you would need to do division to get that number over. If you have addition, you need to do subtraction. The opposite of square is square root. If you have a log, which we won't, you'll need to do a base 10. And then the opposite of sine or cosine or tangent. The opposite of trig is inverse of the trig, which is a button on your calculator, so it's not a big deal. Also in physics, we do a lot of subscripts. Like, I don't know if you see, there's an x. Let's see. There's an x naught. And then there's a vx naught. The 0 is a naught. So there's a lot of subscripts attached to these. There's a t with an s. And those subscripts belong to that variable. They're a package deal. So when you move the v, you're actually moving vxo or vx naught over. So make sure you keep the subscripts with the variable that they are attached to. Like when they say Vx, they mean velocity in the x direction, so it belongs together. And then the 0 usually indicates it's at time 0. Ts would be the tension in the spring, which we'll get to not until spring semester, but really this activity is just to learn how to manipulate equations. Okay, so let's start with this first example. Rearrange for a. So I need a to be on one side of the equation. So let me just go ahead and write the equation itself. MA, that means it's being multiplied together if you don't see an operation. So we have M times A. The issue is I have M there. I need to move M to the other side so that A is alone. That's the goal. Whatever it asks for, you want to make sure that that's alone. So if I want to move M to the other side, I need to think about the opposite operation. So in this instance, if we are multiplying, we need to divide. So I'm going to take that M, divide by M on this side. Whatever you do to one side, you do to the other. That M would cancel. And if I rewrite it, it looks like A is equal to F divided by M. And that would be my final answer. So the next example, it says rearrange for M. So M is going to be our focus. We have k equals 1/2 mv squared. So let me just go ahead and rewrite that. K equals 1/2 mv squared. We have a lot going on that side with m, but just take it step by step, whichever one you want to deal with first. I'll deal with the 1/2 first. So if I want to move 1/2 to the other side, it's 1 divided by 2. If it's being divided by 2, I need to do the opposite. So if to get rid of that divided by 2, I'm going to multiply by 2. Whatever I do to one side, I'm going to do to the other. Okay, so that 2 went away on the right-hand side, and on the left-hand side, I have 2k. And we don't need to take care of that 1 because multiplying and dividing by 1 does not make a difference. So I have 2k equals mv squared. Now, we actually don't need to worry about that squared because I don't need to get v by itself. I just need to get m by itself. And to do that, m is just being multiplied by v squared, so I can move it all over by dividing. So that squared was not even an issue at all. Okay, so it looks like m is going to be 2k divided by v squared. Okay, this one looks like an eyesore. There's a lot going on. It says rearrange for vx naught. So we're looking at that variable right there. right off the bat, I do see that it's squared, so I'm going to have to deal with a square. We have addition. And this looks like it's going to be a lot to handle, but actually this is all one term. And so I could actually move it over all at the same time since they're all attached to each other. But let me show you what I mean by that. Let me rewrite it real quick. Okay, so again, the goal is to get Vx not by itself. So to do that, the first thing I want to do is take this entire add to a x minus x naught. So I can take that whole entire thing and do the opposite operation to get it over. So if this is being added, to move it all over, we're going to subtract. And it's all a bundled package. It's all happening together. Okay, so let me rewrite this. So we have Vx squared and then minus 2ax minus x naught equals Vx naught squared. So I almost have Vx naught isolated with just that one move. It is on one side, but it's not technically by itself. It is still being squared. So to get it completely by itself, I need to knock that square off of it. So opposite of squaring is square root. And I'm going to have to square root everything on the left. So when I do that, we got square root of Vx squared minus 2a x minus x naught. And then now I truly do have Vx not isolated. There's no more squared. So that would be the final answer for that one. Okay, rearrange for ax. Now this one's similar to the last one. We do have some addition. So those little groups will be easy. I can move them over by subtracting. But once I get those moved over, I do have a 1/2 and a t squared. So this one is a bit more difficult. Let's just start with what we know. That kind of looks like it's not a subscript. Let me rewrite that. Okay, so like I said, we need to get this a by itself. So we're going to work on the other things first and kind of work our way inwards until we get to the a. So let's start with this x naught. So the x naught is being added. So to move it over, let's subtract. And it goes away. And then I can treat this Vx naught t similarly. It's being added. We're going to move it over by subtracting. Okay, so let me rewrite that. And then now I've made it kind of to the end term. We have 1/2 ax t squared. I have to get that ax completely alone. This is all multiplication. So I just need to start moving things over. We have a 1/2 in the front. 1 divided by 2. That's kind of how I like to think of halves. It's being divided by 2. So if you're dividing by 2, let's go ahead and multiply by 2. Whatever I do to the left, I do to the right. That 2 goes away. And that last step, I have ax times t squared. Now the squared won't be an issue. It's not actually squaring the a. I just need to move the t squared all together. I can say as one thing. I need to move that over. So t squared is being multiplied. To move it over, do the opposite. We're going to divide by t squared. Running out of room. So our final answer would look like this. Okay. All right, last one, and I'm going to erase the work for the previous example. Okay, let's look at rearranging for k. Now I do see a square root. I see the k is in the bottom of the fraction, which will add another layer. So this one is going to be a bit difficult, but just go step by step. We're going to have to start outwards, work our way inwards. So the first thing I would really want to deal with is that 2 pi. So 2 and pi are both being multiplied. Let's do the opposite. So you get TS divided by 2 pi equals square root of mk. And to continue that and get to the k, I would have to take care of that square root. So to take care of a square root, opposite of square root is squaring. Let me rewrite it up here. So we have TS 2 pi squared equals m over k. All right, so here's the hard part. Anytime the variable it's asking you to isolate is in the bottom of the fraction, that is a problem. This k cannot stay in the bottom. That's not going to work. And so what I would want to do at this point is get it out of the bottom of the fraction. And to do that, you have to move k to the other side. So k is being divided. So to move it to the other side, opposite of division, multiplication. And by multiplying, that gets it out of the bottom exactly like we needed it to be. And that just leaves m by itself, which is not what we want. So we have to go one more step. We have k times all of this. We need to do the opposite of multiplication, which is division. So we're going to have to divide by TS 2 pi squared and do the same on the other side. Okay, so final answer is m divided by TS divided by 2 pi squared. Now I kind of want to show you a trick for dealing with the variable being stuck in the bottom like it was right here, because there is a trick to it and you may run into this a lot in physics. So let me show you what I would do at that point now that I've rearranged equations a lot. Okay, so when you have a variable in the bottom of the fraction, what's essentially going to happen is the variable in the bottom is going to go up to the other side, and then this, whatever's on the other side, will go back down where the old variable was. So essentially they're swapping places. The k will go up, the TS 2 pi squared or whatever it is will go down to where the k used to be. And you'll see in our solution that that's actually what happened. They just swap places. So anytime you have a variable stuck in the bottom of the fraction, just swap places with whatever on the left, bring it over to the bottom of the right. So if you think about it that way, just swapping places, the m's going to stay where it's at. All of this is going to go in the bottom. And make sure you bring everything. So if it's even longer than that, you have to bring everything to the bottom. And then the k is going to slip right where the old TS 2 pi was. So you end up with k equals m divided by TS 2 pi squared, which is what we had. It's just a easier way of thinking about it. That is the pattern. If you have a variable on the bottom, swap the place. All right.